When you stand next to professional golfers, male or female, hitting golf balls, they hit them so far and so accurately, a frequent comment is they play a different game. But what if they do play a different game and use a significantly different mechanism than that used by amateurs? I believe I've found that mechanism and called it the Reiki effect. What I want to show you is that the professional golf swing is not a double pendulum, it's a conical pendulum, which by its nature is not planar and is caused by physics. What's important is that release, including club face closure, does not occur longitudinally around the wrists, but as a conical pendulum release around the lead arm. Before I explain how I've come to these conclusions, I want to go back and quickly look at the history of golf swing research, and where my approach fits in the methodologies that have been used to this point. The first era of research saw the golf swing as a planar model. Both Cochrane and Stobbs and Jorgensen concluded that the swing was a double pendulum, where release occurred longitudinally around the wrist, but also needed a muscle-driven component to straighten the club face. Jorgensen's interest was the Lagrange mathematical calculation of club head speed, and he makes no reference to club face closure. The problem I have with both these models is the description of the wrist as a free joint. The second era saw improved measuring systems. Coleman and Rankin showed that the swing was non-planar. Their measurements showed the arm plane getting steeper during the downswing. The Nesbitt study used amateur golfers rather than professional golfers. His measurement of arm club path differentials of 9 to 12 degrees will be useful a little later. The current era is computer modeling. Biomechanical measurement and analysis is used by universities and companies interested in the 3D nature of the golf swing. Three-dimensional kinematic data is obtained from individual golfers, and from that data swing mechanisms need to be derived. A different approach is mechanical systems modeling. This form of modeling is not well known to the general public, but has become very sophisticated over the last 10 years to the point that mechanical systems can now be designed, simulation tested, and prototype tested to destruction using finite element analysis. When I first encountered this software, I thought that the golf swing is such a precision mechanism that it might be possible to build a theoretical golfer and hence understand what underlying mechanisms enable professional golfers to hit the ball so far. An advantage with this modeling approach is that models can be replayed over and over with different parameter values to help understand the underlying mechanisms. It's this type of software that I've used to build a theoretical golfer model. I started building this three-dimensional golfer model, a computer model of the golf swing, about 6 years ago using commercially available software. I've refined it over the years to a point where I can hit a ball and measure club head speed, ball speed, spin rate, attack angles, etc. However, my primary interest is the golfer and what mechanisms professional golfers use to hit the ball so far and so accurately. In the early days of building the model, I noticed that the club face was closing in the impact zone, and I didn't understand why. I had assumed that I would have had to have added forces or torques by the hands to cause the face of the club to shut so precisely. I called this face closure the Reiki effect, and discovered that the effect was occurring because of some assumptions I'd made when I built the model. The first assumption that contributed to this Reiki effect was the configuration of the lead arm and wrist. The software I was using allowed me to deal with complexities of joints such as different force and torque types, range of motion, end-stop stiffness ranges, etc. So I was able to model precisely what I observed. What turned out to be the most important were, firstly, the separation of the arm rotation and the wrist into two separate joints, a cylindrical joint and a revolute joint. And secondly, the range of motion restriction of the wrist joint that is caused by the ulnar bone. This model is somewhat different to the free joint of Cochrane and Stobbs and Jorgensen. The second assumption was the path the arm takes during the downswing. Top of the backswing is a very important position. We must remember that we're solving differential equations, and the initial conditions of differential equations are very important. This position shows that Tiger has his arm and club positioned at right angles to the spine. It's not pointing at the ball, which we would expect if the arm and club were to follow a plane to the ball. if his arm started parallel to his shoulders at the top of the backswing, then to get to the impact position his arm has dropped by approximately 30 degrees relative to his spine. This is too much of a drop if he was coming back to the planer position. His arm now points well inside the ball. Now at this point I could go to the computer model and show what the effect of these assumptions are on the dynamic behavior of the model. However, the Reiki effect is such a surprising piece of physics. It needs to be seen in real life to be believed. For this reason, I've built this apparatus as a replica of the modeling assumptions in the computer model. We will use this testing apparatus to confirm that what we see in the computer model is correct. The apparatus consists of 2 degrees of freedom at the shoulders, a cylindrical joint to simulate arm rotation along its axis, a wrist joint with a restricted range of motion caused by the ulnar bone, and no flexion degree of freedom. The club is painted red on this side and white on the other, so that you can see any rotation of the club and wrist. This green wire is used to create a transverse force to shift the double pendulum off its plane. The action of the apparatus has been videoed at 240 frames a second and slowed 10 times so that the physics can be seen. Let's now look at a video of the apparatus. First we look at the double pendulum without ulnar bone restriction in its plane. There is no club face closure, so it would be necessary to apply an additional muscle-driven torque to shut the club face. If we now include the ulnar bone restriction, we can see that the club head gets stopped, which is even more reason for a muscle-driven torque. But if we now add this green wire to progressively push the arm off its plane, we see the Reiki effect. Without any applied forces at the wrists, we see the double pendulum morph into a different action which causes the wrist and club to rotate and close very quickly. There's no reduction in club head speed. This is an action of physics and requires that the double pendulum is pushed or pulled off its natural plane. The force must be well timed to cause the Reiki effect. This is not the offsetting of the club off the fixed arm path that Mackenzie showed. You can see with the Reiki effect that the wrist and club rotate as a complete assembly when you see the red side of the club appear. We can now visually compare the double pendulum and the Reiki effect with real professional golfers. You can see the Reiki effect is a good match for the pro golfer swings. The last comparison is my computer model, which shows the same action. Now, what is the simplified physics of the Reiki effect? If we look at the double pendulum at the point where the Reiki effect starts to form, we have a torque T because of the mass M acting around the wrist joint over this length S. What is important is that this torque is reducing as the swing heads towards the impact area. If we now look down the line, we can see that we have an inertial force M acting in the direction of the double pendulum plane. Now, because we've pushed the arm of the double pendulum off its natural plane, we have another torque C caused by the inertial force M acting over this length L. And because alpha is increasing, the torque C is an increasing torque, and it causes a conical pendulum to form, which produces a vertical vector, which will progressively cause the double pendulum to stop. And the conical pendulum will shut the face precisely when the arm and club are in alignment. The conical pendulum will overcome the double pendulum if the conditions are correct. At the impact position, the hand, club and club head have rotated through 90 degrees. All of the angular velocity of the club head that was longitudinally around the wrists has been transformed into rotational angular velocity around the lead arm as a form of conical pendulum with angular velocity of omega. I want to look at this angle beta, which I will call the Reiki angle, because it's very important in the analysis of the golf swing. The Reiki angle of professional golfers can be seen at impact. We can see that the angle at impact tends to be very close to their setup position. It requires a very considerable inward force to counteract the centrifugal forces that are trying to straighten the arm club assembly to produce an angle in the 20 to 33 degree range. When Nesbitt did his study in 2005, he measured the arm club path differential for amateur golfers at between 9 and 12 degrees. Now, I accept that my measurement techniques are very crude, but it appears that professional golfers have Reiki angles in the range 20 to 33 degrees, which is 2 to 3 times amateur Reiki angles. This would indicate that their fundamental mechanism more closely matches the theoretical Reiki effect dynamics rather than the double pendulum dynamics. These golf club testing robots are a special case. They're obviously designed using the double pendulum model and therefore must use gears to close the club face rather than the naturally occurring Reiki effect. I therefore ask the question, do these robots test golf club shafts and heads correctly? I've patented a machine design that will test clubs using the Reiki effect. Why does this Reiki angle matter? As this conical pendulum forms, if beta is small, then omega must increase for a specific clubhead speed. The graph shows angular velocity versus Reiki angle for a clubhead speed of 50 meters a second. If professionals have larger Reiki angles, then they can achieve significant clubhead speeds with relatively low angular velocities of their arm. However, if amateur Reiki angles are in the range 9 to 12 degrees, as Nesbitt measured, then we have a problem. If amateur clubhead speeds are to reach professional clubhead speeds, then arm rotation angular velocities must be in the 6,000 degrees per second range. This will not happen. What's more likely is that there is an angular velocity limit on a human's ability to rotate their arm. This is a biomechanics question that I can't answer, but it does indicate a reason why amateurs are not able to reach professional clubhead speeds. While we're looking at this Reiki angle, I want to have a look at this zone between 0 and about 10 degrees, which impinges on the amateur Reiki angle. It is a zone where a mechanical joint singularity occurs. We've seen that for the double pendulum, the Reiki angle is 0 and there's no club face closure. When the Reiki angle is greater than about 15 degrees, the Reiki effect occurs. When the angle is between 0 and 15 degrees, we get mechanical joint singularity conditions that causes a very significant negative singularity force that will slow the clubhead by up to 40%. I'm not suggesting that humans encounter this risk singularity. I think we've developed the ulnar bone as a means of avoiding the singularity. But the closer we get to the singularity condition, the slower our clubhead speeds will become. I want to now return to the computer model where I discovered the Reiki effect. The Reiki effect is only the starting point. We now have many more questions to answer. How do we maximize clubhead speed? How do we time the Reiki effect? How is timing maintained at different speeds? Why do we hook and slice? How does the shaft flex? It's taken me some years to find the answers to all these questions, and to translate the physics into a golf swing understanding that I could put into practice in my own swing. Ultimately, science and physics are useless unless we can translate them to the enjoyment of a well-struck golf ball. For 50 years I've believed in the double pendulum model. This was a wrong assumption. At age 72, my distances off the tee and irons should be reducing, but they're not. My computer has been my teacher and has taught me the Reiki effect is the fundamental mechanism of the golf swing. My driver distance has increased 60 meters, and I think a further 60 meters is possible if I can find a few core muscles in this whole body of mine. The Reiki effect causes remarkably accurate shots. I've proved to myself that amateurs play the double pendulum game, but professionals play the Reiki effect game. And I've also proved to myself that the Reiki effect can be learnt, so that we can all learn to play the professionals game. Thank you for watching this video. It has taken many years to understand the Reiki effect and the science of golf. Very soon I will be publishing a book which will explain how you too can learn how to hit the ball the way a professional hits the ball.